by 10 cube into within bracket 0.9d plus 2d square, that is equals to 1006.2d plus 2236 d square. Now we have to equate equation 3 and equation 4 to find out the value of d. So by equating this equation we get 1677.08 minus 239.59d minus 266.21 d square plus 1006, that is equals to 1006.2 d plus 2236 d square, or d square is equals to 0.498 d minus 0.67, that is equals to 0. So from this equation we have to apply Sridhar's formula and we can find out small d, that is equals to minus 0.498 plus minus root over 0.498 plus 4 into 0.67 by 2. So d is 0.607 meter. Depth of footing by bending moment criterion. This is the next step. So as by two-way shear, we check that the value of d is 0.607 meter, that means 607 mm. Okay, so the next step is depth of footing by bending moments criterion.
Okay, for bending moment criterion, first of all see this figure, these figures. In left side, the zone of bending moment shown along shorter direction, and in figure of which is in the right side, the bending moment zone is marked for along longer direction. So we have to calculate this value. So for shorter direction, the length along y-axis is definitely 3.6 minus 0.60 by 2, that is equals to 1.50 meter. And for right side figure, bending moment along y-axis, the length along x-axis, the shorter direction is x, that means 1.80 minus 0.3 by 2, that is equals to 0.75 meter. Okay, so now bending moment in longer direction will be 266.21 into 1.80 into 1.5 into 1.5 by 2. So just beside this I have written the formula. So this is as per formula, so that is equals to 539.08 kilonewton meter. Now bending moment in shorter direction, written the formula again. This is equals to 266.21 into 3.6 into 0.75 into 0.75 by 2, that is equals to 269.54 kilonewton meter. Hence bending moment in longer direction is more, so we have to take this for consideration. Now moment of resistance in longer direction mu is equals to 0.138 FCK into d square, that is equals to 0.138 20 into 1800 d square, that is equals to 4968 d square Newton mm. Now we have to equate equation 5 and 6 to calculate the value of d. So that is equals to 539.08 into 10 cube into 10 cube, that is equals to 4968 d square. So d square is equals to 539.0 into 10 to the power 6 by 4968, that is equals to 108510.5. So d is equals to 330 mm or 0.330 meter. Now out of equation A, B and C, the value of equation A, that is 681 mm, is highest. So depth in consideration will be 681 mm. Now using 16 mm dia bar and 50 mm clear cover, we have to calculate overall depth. Capital G is equals to 690 plus 8 plus 50 and the half dia plus clear cover. So that is equals to 748 mm, 750 mm. If the overall depth is 750 mm, then the effective depth small d is equals to 750 minus half dia 8 minus clear cover 50, that is equals to 692 mm. Now area of reinforcement. We have to calculate. This formula is given in Annex G of IS 456 2000. Mu is equals to 0.87 Fy AST to D within bracket 1 minus AST Fy by BG FCK. For longer direction, 539.08 into 10 to the 6 is equals to 0.87 into 415 into AST into 692 into within bracket 1 minus AST into 415 by 1800 into 692 into 20. So this is equals to 249,846.6 AST within bracket 1 minus AST by 60028.92. That is equals to 249,846.6 AST minus 4.168 AST square, or AST minus 60030.41 AST plus 129.5 into 10 to the power 6 is equals to 0. So again we have to apply Sridharacharya's formula. So AST is equals to 60030.41 plus minus root over 60030.41 square minus 4 into 129.52 into 10 to the power 6 by 2, that is equals to 2225 mm square. Now using 16 mm dia bar, the spacing will be 201 by 2225 into 1800, that is equals to 162.60 mm. So we can provide 16 mm dia bar at the rate of 160 mm center to center. Now for shorter direction, 269.54 into 10 to the power 6, that is equals to 249,846.6 AST within bracket 1 minus AST by 60028.92 bracket close is equals to 249,846.6 AST minus 4.162 AST square, or AST square equals AST square minus 60030.41 AST plus 64.76 into 10 to the power 6 bracket close equals to 0. So again apply Sridharacharya's formula, and AST equals to 60030.41 plus minus root over 60030.41 square minus 4 into 64.76 into 10 to the power 6 by 2. So AST is equals to 1098.91 mm square. Now minimum reinforcement at rate of 0.12%, that means 0.12% of area, that is equals to 0.12 by 100 into 3600 into 750 is equals to 3240 mm square, which is greater than 1098 mm square. So as per IS code provision clause number 34.3.1 page 65, reinforcement in central band by total reinforcement in shorter direction is equals to 2 by beta plus 1, where beta is equals to y by x, that is equals to 3.6 by 1.8 equals to 2. Hence reinforcement in central band by 3240 is equals to 2 by 2 plus 1, or reinforcement in central band is equals to 2 by 3 into 3240 is equals to 2260 mm square. So this reinforcement shall be distributed in central 1.8 meter bandwidth as half of 3.6 meter in 1.8 is 1.8. So reinforcement, spacing of 16 dia bars is equals to 201 by 2260 into 1800 is equals to 167.5 mm, say 160 mm. Now provide 16 mm dia bar at the rate of 160 mm center to center in central band. So we have to design differently for central band reinforcement. So balance area of steel to be distributed in outer bands is 3240 minus 2260, that is equals to 1080 mm. So spacing of 16 mm dia bar is equals to 201 by 1080 into 1800 is equals to 335. So maximum spacing allowed is 300 mm or D 692, whichever is less. So we have to provide 60 mm dia bar at the rate of 300 mm center to center for outer bands. Now the last step, we have to check for development length. So so development length we have to check from clause number 26.2.1.1 of IS 456 2000. LD is equals to 0.87 Fy into dia by 4 tau BD is equals to 0.87 into 415 into 16 by 4 into 1.92, that is equals to 752.2 mm. Now available length in shorter direction beyond column face is 1800 minus 300 by 2, that is equals to 750 mm, which is less than 752.2 mm. So hence okay. Now provide 90-degree bend at free end of the reinforcement as per IS code provision. Encourage value of 90-degree bend is 8 dia, that is equals to 128 mm. Okay, so that way we have to provide bend of bar for anchorage. So total anchorage length is equals to 750 plus 128, that is equals to 878 mm, which is greater than 752.2 mm, hence okay. Now see the reinforcement detail. Okay. Here is outer band and here is central band. As for calculation, we have drawn and write this. This is the plan and this is the elevation. So that's all for this lecture. Thank you for listening.